In stats, we started chapter 3. It's called Describing Relationships. I just call it the linear regression chapter. We are looking at whether or not x and y are linearly related. And typically, we call the x variable the explanatory variable and the y variable the response, because we think x is independent, but yet somehow maybe predicting this response. We want to stay away from the word cause, but we think that x is making this response happen, like it's somehow related. Shouldn't say making either. But somehow when x happens, there is another result that happens because of it. So I'm trying to stay away from the word cause. First, we need to understand a basic scatter plot. And I came up with this Big 12 problem. Our textbook uses the SEC division of football, and I figured we should look at our division. So this is last year's data. TCU did pretty good, made it to the national championship, but lost pretty badly to Georgia. So they did have the highest average points per game. Did that predict that they would be top of the division? So here's all the data. And let's start with just a basic scatter plot. So what you do, oh, by the way, it says wins versus points per game at the bottom of the page. Let's briefly talk about that. Trying to get that thing to disappear at the bottom. Okay. When you make a scatter plot, the typical XY coordinate plane is y versus x. So down here, when it says wins versus points per game, it sounds very backwards, but we're putting the wins on the y and the points per game on the x. Please do not ask why they phrase it y versus x when we put the y on the vertical axis and the x on the horizontal, but that's the way stats does it. So we're not flipping any axes. Whatever they list first, they're calling the y. All right? When they use this language of versus. All right? So I'm going to actually call this just Big 12 football. But an alternate title is wins versus points per game. All right? So one more time. Anytime you read some variable versus another variable, the first variable they list, they are calling the y, and the second variable after the verses is the x. But typically in the table, it looks totally normal. X is first and y is second. I don't know, stats just likes to be different, and there you go. You need to go off the min and the max. So maybe add another note above this. I'm going to erase it in a second. So maybe at the top of the page, write scatter axes of scatter plots do not have to start at 0. Use min and max to decide. So for example, in the points per game, I see a minimum of 20 and I see a max of 38. There is no reason to start at 0. Let's start at 20. What if I was to start at 0 and I put 0 here and I put 40 out here? That'd be really bad because 20 would be here, and I'd have dots like this. And I have all this empty space here. That's really bad. I want to zoom in as close as possible to the data. So let's start at the min. And let's go by twos. That's totally up to you. As long as we get to around 38 or 40, I think that's fine. So I'm going to go by twos up to 38. I'm going to spread these out more. Sorry. I don't know. I didn't spread them out much. And then same idea for the wins. Go with your min and max. Getting 0 wins was very possible. So it is possible to have to start at 0, but this starts at 4. So I'd make a mark for 4 and just go by 1s up to 13 in this case. No, I made those pretty close. Oh well. I should have maybe spread them out more, but oh well, we'll still be able to see the pattern if there is one. I'm going to hit pause and make a bunch of dots. You guys do the same, and I bet in a second we will have identical graphs. All right, there's our graph. Hopefully your dots look the same. And I don't know. I took a chance looking at last year's data. Any statistician, it's always a chance. You never know if it's going to show a relationship or not. This one, I don't know. As I scan it left to right, it does look like it's rising, but it doesn't look really linear. I would say because of these two dots, it's strengthening the linear relationship. Because if those two dots disappeared, it looks actually more negative. So we want to be very specific in how we describe this graph. And if you flip to the back, I give you 4 things. I meant to type one more thing, and that is context. So first off, direction. Is it going up or down as you read it left to right? And ours, I think it's going positive. As we go left to right, as one variable increases, the other one is also generally increasing. Form, is it linear, curving, no pattern, or something else? So you need to ask yourself that when you look at the scatter plot and skim it left to right. Strength, is it weak, moderate, or strong in regards to a linear relationship? How close are the dots? To a line. And it's just a guess. We're going to look at correlation after this, and we'll be able to calculate it exactly. But if you're just describing a scatter plot, you are just guessing. And it's important that you throw that guess out there, backed up by how close the dots are. But Some people have a hard time with it because it truly is a guess. Are any values, observations, occurrences far from the pattern? And lastly, use context, of X and Y when describing. So to be honest, in the generic description of a scatter plot, I usually skip the outlier talk and I save that part for specific questions. And we'll look at that here in a little bit. So like when I'm talking about the Big 12 scatter plot, I would say points per game and wins for Big 12 football show a positive. As I skim it left to right, it's going up, right? Let's say moderate. If you said weak, that's fine. But I'm going to say moderate linear relationship. If you want to say something about Iowa State or TCU or maybe Kansas, if you're really on the ball, you can. It doesn't hurt. But those are the main things that I'm looking for. Here, I'll underline them. We got our context. We got our direction. We got our form and strength. So those are the big ones that I'm grading. All right? If you want to talk about outliers in this generic description, you can. But I'll specifically ask that in a question like this at the end of your handout. What effect does Kansas have? What effect does Iowa State have on the relationship? Or it might specifically say, are there any unusual observations? And then that's your moment to talk about it. All right? Next, let's look at how we can precisely calculate the strength. So that's correlation, and the first step is getting it from the calculator. It's a pretty horrible formula if you do it by hand. There it is. Look at the formula that says R right there. It's not fun to do by hand, but the calculator does it very easily. So in your calculator, you might open up a spreadsheet and type all the data in. I'll hit pause and let you catch up, or maybe you hit pause. Yeah, you do that. Hit pause, type it in, and let's walk through these steps. So if you typed in all your data, make sure you name the two lists. And then you press Menu, Stats, Stat Calculations. Let's back up again if you're writing this down. Menu, Stats, Stat Calculations, and then we want the fourth choice right here. It says A plus BX. In stats, they like to use the letter B for slope. It's kind of weird because in algebra you use that as y-intercept, but in stats, B is the slope. So you pick that, you type in your names of your lists, and press tab all the way down to the bottom, hit OK, and it gives you some data. That's your y-intercept for the best fit line, A. B is the slope. R squared, we'll talk about that later. And there is correlation, 6894. So in the handout, you might write all of that down. But correlation goes right there, 6894. Now notice it does say to interpret, so we'll do that in the next lesson. All right, see y'all later. Bye.